Hello. Mm.
Should I wait for the others to join?
1 moment, please. Okay, guys. Good morning. Today the classroom is the math. The teacher is the Professor Sat. Professor Sat is ready for you?
Yes. Yes.
Okay. Thank you.
All right. Okay. So today we are going to start with the properties of real numbers and then in the next part we will see about writing and solving linear equations. Okay. So let's start with the real numbers. Good morning, sir. Good morning. So let's start with the real numbers. So let us see what the real number is. So first of all, the numbers started like the numbers, like when the people needed to count, they started counting 1, 2, 3, 4. Okay. And those were the natural numbers, like, or you can say counting numbers. Okay, these were 1, 2, 3, and like this. Then the presence of nothing, like let's say there was nothing to count, then that comes here, and that was added a 0 in it. So it becomes whole numbers. We added these numbers are 0, 1, 2, 3, and up to so on. But then we realized that there is something which is like the negative numbers. So there then comes the negative numbers. So negative numbers, these are called integers. It includes the positive numbers and the negative numbers. It includes like 0, plus, minus 1, plus, minus 2, plus, minus 3, so on, all the numbers up to there. And then we realized that there are some numbers that are the decimal numbers, like, or the fractions. There is some numbers like decimal numbers or the fractions. So we call them the rational numbers. Rational numbers. These are the rational numbers. Let me write it separately here. These are the numbers that we can write in P over Q form. Okay, and Q cannot be 0. If we can write any number like this in a fraction, that's a rational number. Let's say 2. 2 itself is a rational number because we can write it 2 over 1. Like 0.1 is a rational number because we can write it as 1/10. So these are the rational numbers. But then we thought, okay, we got all the numbers that we needed, but then there were some numbers which were not able to be written like this. We were unable to write them in P/Q form, like square root of 2. It's a decimal number, which is never ending and never recurring number. So square root 2, square root 3, the most famous number pi, okay, 3.141, and so on, like going, keep numbers to go, keep going. You cannot write it into a fraction. So those numbers were discovered, and these numbers were called the irrational numbers. Okay? Those numbers are irrational numbers. The rational numbers and the irrational numbers, they are different. Okay, let's see. Now, okay, so now when we added this plus this, everything in rational numbers and irrational numbers, that combine up to be real numbers. These are all the real numbers. So now let's have a look at some examples or some properties of real numbers. So for example, let's say 2.3 is a real number, square root 2 is a real number, -5 is also a real number. Any number that you can think of that's not an imaginary number or the complex number, those all are the real numbers. So let's some properties of real numbers. Okay, so in the properties, we can see that there is, let's say the first one is commutative property. Let us have some numbers, let's say A, B. We will use some numbers. Let's say we have two numbers, A and B. Let A and B are real numbers. Then we can do is, we can write them A plus B is equals to B plus A. So these numbers are commutative. Commutative means like you can add them, add A from the left side, or you can add A to the B from the right side. You will get the same answer every time. Let's say 5 plus 4 is same as 4 plus 5. That's 9, and that's also 9. So these numbers are commutative numbers. Next one is that comes after the commutativity is associativity. So associative property. Let us have three numbers, three real numbers. Let X, Y, and Z are real numbers. Then what we can say, that X plus Y plus Z is equals to X plus Y plus Z. And this property, this is for addition. And addition or subtraction, same thing. And then there is another one, which is for multiplication, like X times Y times Z is same as X times Y times the Z. It means either you multiply, also like, let's talk about the addition one. So in addition one, it means if either you add y and z first, and then you add the x, it will give you the same answer if you will add the x and y first, and then you add the z. So you can add it in any way. So this property is called the associative. And similarly in multiplication, either you multiply them two numbers like y and z first, and then multiply it with x, it will give you the same answer as you multiply x and y first, and then you multiply it with z. Let's say, for example, we have 3, 2, and 5. These are our real numbers. So let's try 3 times 2 times 5. It will be equals to 3 times 2 times 5. So 3 times 2 is 6. So 3 times 6, oh sorry, 10. 2 times 5 is 10. 2 times 5 is 10. So 3 times 10, and here we got 3 times 2 is 6 and times 5. So 3 times 10 is 30, and 6 times 5 is also 30. So the ordering does not matter. Either we multiply these first or we multiply these first. Okay, so next one is the distributive property. Let's say again, let's say we have three numbers, okay? Let x, y, z are real numbers. Then the distributive property is like this. So let's say we have x times y plus z. This is called the distributive property of multiplication over addition. Okay. So how we can write it? It's same as x times y plus x times z. We can distribute this number inside among them like this. So it's the distributive property. So these numbers, so the real numbers have the distributive property. Let's say again we take the same numbers. Let's say we have 3, 2, and 5. So 3 times 2 plus 5, it should be equals to 3 times 2 plus 3 times 5. Okay, so let's do that. So add them first. 2 plus 5 is 7. So 3 times 7. This is 6 and then 15. So 3, it's 21. So you see 21 is equals to the 21. So these are like the basic sum properties for the real numbers. There's one more that we can see. That is called identity. Identity property. Identity property means they have the identity element, identity number. Let's say the additive identity is 0, or you can say the additive identity is 0 in real numbers. Okay. Is equals to that thing. So 0 do not change the identity of the
Okay, guys, we have to wait a couple of minutes because the teacher have some trouble with the connection, but just wait, okay? Do you hear me, guys? Okay.
Sorry about it. My Zoom crashed. Sorry. Apologies. Okay, so the next one is like okay, we were about the properties. So next property was we looking at is identity. Okay. Identity property. So the real numbers have the identity, additive identity and multiplicative identity. That is, additive identity is 0. Okay, so like 0 plus something is something plus 0 is equals to 0 or a. The thing is remains the a. Let's say a is a real number. We add it with 0, either from the left side or the right side. It remains the a. So that's the additive identity for addition. And if we multiply something with the 1, either like this, it remains the same. So so 1 is the multiplicative identity. Okay, this one is the multiplicative identity. 1. Okay. And additive identity is 0 in real numbers. Okay, so these were the basic properties. Now let's have a look at the linear equations. Linear equations. So first of all, we see how to write them or how to solve them. Let's start with, okay, so let's look how we can write them and then we'll see how we can solve them, right? So there is basic 3 forms to write a linear equation. The first one you might be familiar with. It's very common, y equals to mx plus b, where m represents the slope and b represents the y-intercept. And this form is called slope-intercept form. Okay. Then next one we have y minus y1 m into x minus x1. Okay. And for this form, this one is called the slope point form. This one is slope point form. M is slope and x1, y1 is point. Then the next one is standard form. That is ax plus by equals to c. Here, where a, b, and c are numbers, are real, and x and y are the variables. So the next thing that is in this equation is is slope. So slope is represented by n. It tells us the change in y variable with respect to the change in x variable. It's also sometimes represented by this thing delta y over. So like we look how much change happens in y when we do some change in x. Okay, let's say like just a quick idea. I can show, like we can have a graph. Let's say this is, we have a line. Let's say this is the point 0, 1. And let's say there is another point 2. This is 2 here, down there. So let's say there is another point 2, 4. Or let's say 2, 5. Let's see. And we have a line through them. And we call these linear equations because when we graph them, we get the lines. When we graph them, we get the lines. So this line have a slope. This line have a slope. And how we find it? We find how much change in x there, from there to there. That's the change in x. And then we measure the change in y up there. That's the change in y. So this thing, this is the slope for this line. Right? And there is 2 more forms for the line. Okay. That is, if we have x equals to b. All right, x equals to b. That's one form that we can see. And the y equals to some number a, right? B is a number, a is a number. A and b are the real numbers. So x equals to b is a vertical line. X equals to b is a vertical line. Let's say x equals to 5. That's a vertical line at 5. It's solid. I'm just like, this is the line x equals to 5. It's a vertical line and it have infinite slope, or you can say it have undefined slope. And then we can have the lines, let's say y equals to 3. So y equals to 3 is a horizontal line. Actually, this is x, this is y. So y equals to 3 is a, let's say this is, there it is 3 on the y-axis. So this is a horizontal line. Y equals to 3 is a horizontal line. And the horizontal lines have 0 slopes. So if we are given some different forms, we can convert one form into another form by using different type of writings. Let's say I have 5x plus 3y equals to 15. This is in standard form. This is a standard form. And I want to convert the standard form into, let's say we want to convert it into intercept form. Yeah. We want to convert from there to there. So what we do, first of all, we move the x term to the other side, or you can say we subtracted 5x on both sides. So 3y will be equals to 15 minus 5x. And then in the next step, we need to get rid of this 3 from here, the coefficient should be 1. So we will divide it by the 3. Okay. I'm just rearranging it a little bit. So I'm writing the 5x first. And I'm just plus I'm also rewriting it by making 2 different fractions by divide. Okay, so and then what we get the final answer here, y equals to minus 5 over 3x plus 5. So now we can see it's in the form y equals to mx plus b, where now y equals to minus 5 over 3x plus 5. So it means the slope m is minus 5 over 3 and the intercept is 5. So if we are given in one form, we can convert it into another form. Okay. Okay, now let's try some basic examples with the linear equation that we can use. Let's say, let's start with some very basic example. We have a word problem. Let's say the sum of two numbers. The sum of two numbers is 25. Okay, sum of two numbers is 25. Another information that we have is one number one of the numbers exceeds other by 9. So we want to find that number, find that, or you can say is find that number or find those numbers. Okay, we need to find those numbers. All right, so let's say we are saying the sum of two numbers is 25. So let's say we have two numbers, a plus b, right? And their sum is 25. Then we know that one of the number exceeds the other number by 9. Then we know that, let's say the a is equals to b plus 9, because a exceeds the other number by the 9. So now we can replace the a here by this. Okay, so we will have b plus 9 plus b equals to 25. So b plus 9 plus b, removing the parentheses, 25, right? And so 2b plus 9 equals to 25. So we subtract the 9 on the both sides. So 2b is equals to 25 minus 9. So 25 minus 9 is 16. So 2b is equal to 16. So b is equals to 8, dividing both sides by 2. So now one of the number is 8, right? That's the b. How we can find the a? We can find the number a from here. Okay. So a is equals to b plus 9. All right. So it means that b is 8, right? A is equals to 8 plus. So that will be wait. Yes, so that will be 17. Okay. So a is 17 and b is 8. So if we will add them, their sum will be 25, and one number is 9 more than the other one. This is the these are the problems in one variable. Like these are we did not include the y in it, right? So let's say we try to solve the linear equation into, like, we have two equations and two variables. Let's say we have an equation x plus 2y equals to 4, and let's say we have 3x plus 4y equals to and let's say equals to 10, right? Now we have two linear equations. Let's call this A and let's call this B, right? So now we want to solve them. There is 2 or 3 different methods to solve the linear equations like this. One of them is called elimination method. And another one is called substitution method. And the third one is graphical method. Like we can graph them and then we can see where those two intersect. These two lines intersect. That's the graphical method. But right now, let's try it. Let's see from here. Let's say we have A and B. Let's try it first with the substitution method. So we take the equation A. Okay, first of all, we write the equation A. And what we do is we subtract the 2y on both sides. Now we have x equals to 4 minus 2y. Now we substitute into B. Okay, substitute into equation B, the x value. So 3 into 4 minus 2y plus 4y equals to 10. All right, so 3 times 4 using the distributive property of real numbers that we saw before. Okay, we can distribute it. So 3 times 4 and minus 3 times 2y plus 4y equals to 10. So 3 times that's 12 minus 6y plus 4y equals to 10. So now let's combine the like terms, these two. So 12 minus 2y equals to 10. And let's subtract the 10, or let's subtract the 12 on both sides. Okay. So we will get minus 2y equals to minus 2. All right. And then we will divide both sides by -2. So we will get y equals to 1. Yes, y is equals to 1. Right. So this is our point. Y equals to 1. That's the one value from here. Now we take this. And substitute it in there. Like this, the value of the y here. So x equals to 4 minus 2 into 1, because y is equals to 1, right? So x equals to 4 minus 2, that's just 2. So x equals to 2, right? So we have x equals to 2 and y equals to 1. And we can write the solution like this, 2, 1. So this is the point where both of these lines intersect, right? Okay. We can also do this same problem. We can also try the same problem by using the elimination method. Let's try the elimination method for this. We have x plus 2y. X plus 2y equals to 4. And we have x plus. Okay, so now let's try it with the elimination method. So in elimination method, we want to eliminate one of the variable by either adding or subtracting the equations. We can multiply any equation by any number on both sides. It do not affect the equation. So let's say the coefficient of this one is 1, right? And the coefficient of the y is 2. So if I multiply the equation A by the 2, or you can say by the -2, then the coefficients of y and the y's, they will become opposite. So let's multiply the equation A. Multiply the equation A by, we can multiply it by 2 and then can subtract, or we can directly multiply it with -2 to make these and these opposite. We want to make these coefficients opposite. So now we are multiplying the equation A by the 2, -2. So we will get -2 into x plus 2y, 4 times -2. Whatever you do it on both sides. So you will get -2x, -4y equals to -8. Now this is our new, we can give this a number, let's say C. Okay. So this is our new equation, which is equivalent to A. It is exactly equivalent to A. Now let's have the equation B here. 3x plus 4y equals to 10. Let's have it here. Now what we do is we add them. Okay. Now what we do is we add them, because you see their coefficients are opposite. So if I will add them, they will become 0. They will be eliminated. All right. So -2 plus 3, that will give us x. So this 4 minus 4, it will become 0. And 8 minus my -8 plus 10 is 2. So we get x equals to 2. Okay. Now we still need to find the y. We are done with the x, but we also need to find the y. So to find the y, we can use any of the given equations. This one, or even the one that we modified, even this one. No problem with using any of the equation. So let's use the A, all right? Or we can use the B. Let's use the B. So 3x plus 4y equals to 10. Now x is 2. Now our x is equals to 2. So 3 times 2 plus 4y equals to 10. So 3 times 2 is 6. 3 times 2 is equals to 6 plus 4y, that is equal to 10. So we subtract the 6 on both sides. That will give us 10 minus 6, that will be 4. Okay. 10 minus 6 is 4. And then the next one we will divide by the 4, we will get. So you see, it does not matter. It does not matter which method we adopt. Either we adopt the elimination method or we adopt the substitution method, we get the same answer. Now let's try one more word problem, okay? And in 2 variables. Word problem in 2 variables, okay? So the problem that we have is, let's say, okay, we can use. So let's say, Joe's age is Joe's age is 3 times the sum of ages of his 2 sons. After 5 years, his age will be twice. His age will be twice the sum of ages of his 2 sons. So we need to find the age of Joyce. Okay, so we need to find his age. So let's start with the given information that we have. We know that Joyce's age is 3 times the sum of the ages of his son. Okay, so now let's try to solve it. So we say that, okay, let x equals to the one that we find, so is it okay, and y is equals to sum of ages of son. Right, now we define, first of all, what we do, we define our variables x and y. We want to see what does the x represent, or whichever variable you want to, like a, b, any number that you want to take is that. Okay, so let's take this, x is the Joy's age, and then the y represents the sum of the other's age. So what information we have? His age is 3 times the sum of the ages of his 2 sons. So the sum of ages of 2 sons is represented by the variable y. The sum of his 2 sons, ages of 2 sons, the ages of his 2 sons is y. And so Joy's age is 3 times that. So x is equals to 3 times the y. X is equals to 3 times the y. And let's call this our first equation. Okay, equation number 1. How? Okay, so first of all, we converted the given information into an equation. First of all, we defined the variables, then we convert it into an equation, into a linear equation. All right, it's a linear equation. If you want to see, it's like this: x minus 3y equals to 0, which is standard form of linear equation, right? So we don't need to do this, just showing you that this is a linear equation and you can rewrite it into standard form, right? If you want to. to see if it's a linear, but we also know that it's linear equation because the exponents on x and y, the exponents on the x and the y are also 1. So if the exponents on x and y are on all the variable is 1, then it's a linear equation. Okay, so now the second thing is what we are saying. The second part is after 5 years, his age will be twice the sum of ages of his son. Okay, so after 5 years, we say that the x is his age, right? So after 5 years, his age will be x plus 5, right? That will be the Joy's age, the x plus 5 after 5 years. And we are saying it will be equals to 2 times the sum of his son's age. But let's say the sum of his son's age right now is y. Then after 5 years, how much it will be? It will not be y plus 5, because we are talking about the sum of the ages of his 2 sons. Okay, so each one will increase by 5. So x plus 5 plus 5. So 5 for the 5 years for one son and 5 years for another son will add up in the sum here. So x plus 5 equals to 2 times the y plus 10. All right, let's solve it. So x plus 5 equals to 2y plus 20. And x plus 5 equals, okay, wait, sorry, my bad. We should subtract the, let's combine the like terms. Let's move the numbers to the other side and variables on one side if we want to, or okay, so let's do that. X minus 2y equals to 20 minus 5. So we subtracted 2y on both sides and 5 on both sides. So x minus 2y is equals to 15. Okay, now we have two equations, equation 1 and equation 2. The equation 1 tells us that x is equals to okay, so the x is equals to 3y. So here we get 3y because x is equals to 3y. All right, so we substituted the x by the 3y. Okay, let me write it with a different color. So okay, so we did the substitution, 3y for the x, all right, and minus 2y. All right, so 3y minus 2y is just y. So y is equals to 15. All right, so y is 15. So it means the x is equals to, using this equation here, if y is equals to 15, then x is equals to 3y, right? So 3 times 15 is 45. So Joe's age is 45 after 5 years. Okay. Okay, so at the end, okay, let's conclude it. So let me write a problem for you that you can try if you wanted to. Okay, so let me just write a problem. Okay, so the middle digit of a number that is between 100 and 1000 is 0. And the sum of other digits is 13. Okay. Okay, the next information is if the numbers, or you can say digits, right? Sorry, not the numbers. The digits are reversed. The digits are reversed. The number so formed exceeds the original by 495. Okay, so find that number. So what we have here is the middle digit of a number that's between 100 and 1000. So how many digit numbers are in between 100 and 1000? Those are 3-digit numbers, like from 101 to 999. Those numbers can be in between 100 and 1000. So that's a 3-digit number. And the middle digit is 0. And the sum of other two numbers, sum of the first and the last number is 13. And if you reverse, if the digits are reversed, like let's say if it is 231, reversed means 132. The middle number will stay at its place. So that's what it reversed means. Yeah. So if the number is reversed, okay, the number, that new number that you get exceeds the original number by 495. 495. So you have to find that number. So if you have any if any of you want to have any question about this, you can ask, or otherwise you can, it's just a question for you at the end.
Guys, everything is clear? If you have some question, you can
Yes,
go
please,
on.
if you have any question related to this question or any of the previous thing that we did, please just ask. Or if you want me to, I think it's, so if it's okay from you, then I will conclude my lesson here. Is it clear with everyone?
Guys, it's clear. If you want some question, you can turn your microphone and ask the question to the teacher, okay? It's clear?
All right, okay then.
Okay. The class is done, teacher, right?
Okay, everyone, then have a good rest of your day.
Okay, guys. Thank you so much, Seth.
You're welcome.
Have
Bye,
a
everyone.
wonderful day. And guys, thank you for being here and be pending for next class, 3 p.m. today in Spanish. So I want to see you tomorrow in English class. Okay, enjoy the day and wonderful day to all of you. Bye-bye. Bye, Samuel, Santenhofer, Joseph, Dennis.